Right now, as you watch this video, something impossible is happening. The screen you're staring at is using light to literally control your thoughts. Not metaphorically, literally. Photons are carrying structured information from my mind to yours at 186,000 miles per second. And when they hit your retina, they're triggering cascades of chemical reactions that are rebuilding my ideas inside your brain. You think you're just watching a video, but you're actually experiencing one of the most profound mysteries in physics. How can something with no mass, something that doesn't even exist in one place at a time, hold and transfer information? Here's what's going to shatter everything you think you know. The light hitting your eyes right now is simultaneously a wave and a particle, exists in multiple states at once, and is literally rewriting the structure of your neurons. Every word you're reading, every image you're seeing, every thought I'm putting in your head exists because we learned to trap information inside something that weighs nothing and moves faster than anything in the universe. And here's the thing that's going to haunt you after this video. Everything you've ever learned, every memory you have, every idea that makes you who you are came from light carrying information into your brain. You are, in a very real sense, made of organized light patterns. But before I blow your mind completely, do me a favor. Hit that like button and subscribe, because what I'm about to show you will fundamentally change how you see reality. And drop a comment telling me what country you're watching from and what time it is where you are, because I want to know how light is carrying this information across our planet right now, connecting all of us in this shared moment of understanding. Let's start with something that seems simple, but is actually impossible. You're looking at your screen right now. What's actually happening? Your screen has millions of tiny lights called pixels, and they're flickering on and off thousands of times per second, changing colors in precise patterns. Those patterns create images, which create meaning, which creates thoughts in your head. But here's the question nobody asks. How does a pattern of blinking lights become an idea? Think of it like this. Imagine you're standing on a beach at night, and you see someone far away flashing a flashlight in dots and dashes. Morse code. The light itself is just light, just photons bouncing around. But the pattern, the timing, the sequence, that's information. The person isn't sending you photons. They're sending you a message using photons as a carrier. The information isn't in the light itself. It's in how the light is organized. This is the first mind-blowing concept. Information is pattern, not substance. You can store the same information in light, in electricity, in sound waves, in magnetic domains on a hard drive, in the grooves of a vinyl record, even in the arrangement of knots on a string. The Inca Empire had no written language, but they stored complex information about their entire civilization using quipu, strings with knots tied at different positions. Same information, completely different medium. But light is special. It's the fastest thing in the universe. It can travel through empty space, and most importantly, you can manipulate it in ways that are impossible with any other information carrier. And this is where things get weird. In 1887, a scientist named Heinrich Hertz was doing experiments with radio waves, which are just light with really long wavelengths. He discovered something strange. When light hit certain metals, it knocked electrons loose. This made no sense with the physics of the time. If light was just a wave, like everyone believed, then dim light should knock electrons loose slowly, and bright light should knock them loose faster. But that's not what happened. Dim light of the right color knocked electrons loose immediately, while bright light of the wrong color didn't knock any loose at all. Albert Einstein figured out what was happening in 1905, and it won him the Nobel Prize. Light isn't just a wave, it's also made of particles called photons. Each photon carries a specific amount of energy based on its color, and when a photon hits an electron with enough energy, it kicks it loose instantly. This discovery, called the photoelectric effect, completely changed physics and ultimately made your phone, your computer, your TV, and every digital device you own possible. Here's why this matters for storing information. If light is made of particles, then you can count those particles. And if you can count them, you can use them like tiny messengers, each one carrying a bit of information. A photon present equals 1. No photon equals 0. Binary code, but made of light. But we can do something way more sophisticated than that. Remember how I said each photon has a specific energy based on its color? Well, we can use different colors to represent different information. Red light carries different information than blue light. You can send multiple messages simultaneously on different colors of light on the same fiber optic cable, a technique called wavelength division multiplexing. It's like having multiple conversations in the same room, where each person speaks in a different pitch, and you can listen to all of them at once by tuning your ears to different frequencies. Think of it like a piano. When you play a note, you're creating a sound wave at a specific frequency. Middle C vibrates at 261.63 Hz. Every piano in the world plays that same frequency for middle C. Now imagine you could play multiple notes simultaneously, and someone listening could separate those notes and read a message encoded in which notes you played and when. That's essentially what we do with light. The fiber optic cable connecting continents under the ocean right now is carrying trillions of bits of information per second using this technique. Different colors of light, pulsing on and off billions of times per second, carrying Netflix streams, phone calls, messages, everything that makes the internet work, all traveling through a glass thread thinner than a human hair. Now here's where things start getting genuinely strange, and this is the first moment where your brain is going to resist what I'm telling you, because it sounds impossible. But it's not just true, it's experimentally proven, and it's happening to the light hitting your eyes right now. Light is simultaneously a wave and a particle. Not sometimes a wave, and sometimes a particle. Not a wave that acts like a particle. Literally both at the same time until you measure it. This is called wave-particle duality, and it's one of the foundations of quantum mechanics. In 1801, a scientist named Thomas Young performed an experiment that should have settled the question of what light is forever. He shined light through two narrow slits onto a screen and expected to see two bright lines. Instead, he saw multiple bright and dark bands, an interference pattern. This proved light was a wave, because only waves interfere with themselves like that. When two waves overlap, they can add together to make a brighter spot, or cancel out to make a dark spot. Particles can't do that. Case closed, right? Light is a wave. Except then Einstein discovered photons, and suddenly light was particles again. So scientists repeated Young's experiment, but this time they sent one photon at a time through the slits. One single photon. Which slit does it go through? Both? Neither? It's a particle. It has to go through one or the other. Here's what will blow your mind. Even when you send one photon at a time, the interference pattern still builds up over time. Each individual photon creates a single point on the screen, but the accumulated pattern of thousands of individual photons shows the wave interference pattern. Each photon is somehow interfering with itself, going through both slits simultaneously. But wait, it gets weirder. When scientists put detectors at the slits to watch which slit each photon goes through, the interference pattern disappears. The photons start behaving like particles, going through one slit or the other, creating two bright lines instead of many. The act of observing which path the photon takes changes the outcome of the experiment. Think of it like this. Imagine you're watching a soccer game, and every time you look at the ball, it's in one specific location. But when you're not looking, the ball exists in a fuzzy cloud of probability spread across the entire field. The moment you look again, the cloud instantly collapses to a single point, and there's the ball. That's quantum mechanics. That's how light actually behaves. That's reality. This has profound implications for storing information in light. In classical information theory, A bit is either 1 or 0, off or on, black or white. But a quantum bit, a qubit, can be both simultaneously until you measure it. A photon can be in a superposition of multiple states at once, meaning a single photon can theoretically carry more information than a classical bit. In 1994, Peter Shor, a mathematician at MIT, developed an algorithm showing that a quantum computer using qubits could factor large numbers exponentially, faster than any classical computer. This was terrifying, because modern encryption relies on the fact that factoring large numbers is computationally impossible. If someone builds a working quantum computer, they could break virtually all current encryption methods. The information you think is secure isn't. But here's the beautiful paradox. Quantum mechanics also gives us quantum encryption, which is theoretically unbreakable. If you encode information in the quantum state of photons and send those photons to someone, any eavesdropper trying to intercept the message would have to measure those photons, which would collapse their quantum state and reveal the eavesdropper's presence. It's information security guaranteed by the laws of physics themselves. Let me tell you about the moment that changed human civilization forever, and you've probably never heard of it. In 1966, Charles Cowell, a physicist working at Standard Telecommunication Laboratories in England, published a paper suggesting that optical fibers made of ultra-pure glass could carry information using light much more efficiently than copper. Wires carrying electricity. At the time, glass was so impure that light could barely travel a few meters through it before being absorbed. Cowell calculated that if glass could be made pure enough, light could travel dozens of kilometers without significant loss. Everyone thought he was crazy. Glass was glass. You couldn't make it pure enough, except he was right. By 1970, Corning Glass Works created the first optical fiber that met Cowell's specifications. In 2009, Cowell won the Nobel Prize in Physics. And by then, optical fibers had literally rewired the planet. Here's the scale of what happened. In 1988, the first transatlantic fiber optic cable, TAT-8, was laid on the ocean floor, connecting the United States and Europe. It could carry 40,000 simultaneous phone calls. That seems impressive until you realize that today's cables carry tens of terabits per second, the equivalent of hundreds of millions of simultaneous phone conversations, thousands of HD video streams, all the data traffic of the internet flowing through hair-thin strands of glass. Think of it like this. Imagine you had to communicate with someone on another continent using only carrier pigeons. Each pigeon can carry one letter. To send a book, you'd need thousands of pigeons, and it would take weeks. Now imagine you could somehow train those pigeons to fly at nearly the speed of light and carry millions of letters simultaneously. That's the difference between copper wires and fiber optics. That's the difference between the pre-internet world and now. But the truly mind-bending part is how we manipulate light to store this much information. We don't just turn light on and off. We modulate its amplitude, how bright it is. We modulate its phase, which part of the wave cycle it's in. We modulate its polarization, the direction the wave oscillates. We modulate its wavelength, its color. We can even modulate the shape of the beam itself, using orbital angular momentum, which makes the light spiral like a corkscrew. And different spiral directions carry different information. In 2016, researchers at the University of Southern California demonstrated a system that transmitted 1.44 petabits per second through a single optical fiber using all these techniques simultaneously. That's 1,440,000,000,000,000 bits per second. To put that in perspective, that's enough bandwidth to download every movie ever made in about 1 second, through a single strand of glass thinner than your hair. Here's what nobody tells you about this. The information isn't actually stored in the glass. The glass is just a guide, keeping the light from spreading out and losing coherence. The information is stored in the structure of the light itself, in the patterns of photons marching through the fiber in precisely choreographed arrangements. The glass is the stage, but the light is the dancer, and the dance is the message. And this is happening right now, under your feet, under the ocean, all around you. Every building in every city has fiber optic cables running through it. The internet backbone, the major arteries carrying the bulk of global information, is entirely optical. When you send a message, when you watch a video, when you make a video call, that information is being converted into patterns of light, shot through glass at 200,000 kilometers per second, and reconstructed on the other end. Your thoughts, encoded as electrical impulses in your brain, transmitted as typed characters, converted to light pulses, transmitted across continents, converted back to electrical signals, and reconstructed as thoughts in someone else's brain. Your consciousness, temporarily encoded as light. What if I told you that you could store every book ever written in a piece of glass the size of a coin? Not just theoretically, but with technology that exists right now that you could go buy if you had enough money. This is holographic storage, and it's going to make you rethink what's physically possible. You know what a hologram is, right? A three-dimensional image created by light. You've seen them on credit cards, in museums, maybe in Star Wars. But here's what most people don't understand. A hologram isn't just a picture. It's a complete record of a light field, containing information about both the intensity and phase of light waves. Every point on a holographic plate contains information about the entire image. If you cut a holographic plate in half, you don't get half the image. You get the full image, just slightly less detailed. This property, called redundancy, makes holograms incredibly robust for data storage. In 1963, Peter J. Van Heerden at Polaroid Corporation realized you could use this principle to store digital information. Instead of recording images, you record patterns of light and dark representing binary data. But here's the revolutionary part. You can store multiple holograms in the same physical space by changing the angle of the reference beam or the wavelength of light used to record them. Think of it like this. Imagine a library where instead of books side by side on shelves, every book is written in the same space, but in different colors of ink. Red ink for one book, blue ink for another, green ink for a third. When you want to read a specific book, you just put on glasses that filter for that color. That's essentially how holographic storage works. Different patterns of information exist in the same physical location, distinguished by the wavelength or angle of the light used to retrieve them. In 2012, researchers at the University of Southampton demonstrated a method of recording data in fused quartz glass using femtosecond lasers, creating tiny structures called nanogratings. They stored 360 terabytes of data in a disk the size of ACD. The data is stable at room temperature for billions of years. They call it 5D optical storage because it encodes information in 5 dimensions. The 3 spatial dimensions of the nanostructure's position, plus the size and orientation of the structure. Let me make this concrete. You could store the entire contents of the Library of Congress, every book, map, photograph, recording, everything in a piece of glass smaller than a smartphone. You could store every photo you've ever taken, every video you've ever watched, every document you've ever written, in something you could wear as a pendant. And it would last longer than human civilization has existed so far. But here's where this gets genuinely strange. The information isn't really in the glass. The laser creates permanent changes in the molecular structure of the glass, tiny regions where the refractive index is different. When you shine light through at the right angle and wavelength, those regions diffract the light in specific patterns, and those patterns encode the information. The data is stored in how the material interacts with light, in the conversation between photons and matter. This reveals something profound. Information storage isn't about putting something somewhere. It's about creating structures that cause light, or electricity, or magnetic fields, or any other physical phenomenon to behave in predictable, meaningful ways. A book stores information in patterns of ink that reflect light differently than paper. A hard drive stores information in magnetic domains that affect the flow of electrons. Holographic storage stores information in structures that diffract light. The medium changes, but the principle is the same. Create a pattern that light can read. Now, I'm going to tell you something that sounds like science fiction, but is absolutely real and is happening in labs right now. Scientists are using light to store information in DNA. And when I explain how and why this works, you're going to see that the line between biology and technology, between life and information, is far blurrier than you ever imagined. DNA is famous as the molecule that stores genetic information, the code that makes you who you are. It's made of 4 chemical bases: adenine, thymine, guanine, and cytosine, abbreviated A, T, G, and C. The sequence of these bases along the DNA strand encodes the instructions for building proteins, which build your body. But here's the thing. DNA is just an information storage medium. A really, really good one. In terms of information density, DNA is unmatched. 1 gram of DNA can theoretically store 215 petabytes of data. That's 215 million gigabytes. That's 215,000 terabytes. Every movie ever made, every song ever recorded, every book ever written, every photograph ever taken, all of human knowledge could fit in a space smaller than a sugar cube. And it would last for thousands of years if stored properly. In 2012, George Church at Harvard Medical School encoded his book, Regenesis, into DNA. All 53,426 words, along with images, into 54,898 DNA strands stored in a tiny droplet. In 2013, researchers at the European Bioinformatics Institute stored 739 kilobytes of data in DNA, including audio files, text documents, and images, then successfully retrieved it with 100% accuracy. In 2017, a team at Columbia University and the New York Genome Center stored a complete computer operating system, a movie, and other files in DNA. But here's what connects this to light. You read and write DNA using light. DNA synthesis, the process of creating custom DNA strands, uses photolithography, the same technique used to make computer chips, which uses light to pattern materials at microscopic scales. When you sequence DNA to read the information, you often use fluorescent markers, molecules that absorb light at one wavelength and emit it at another. You shine light on the DNA, and the light that comes back tells you the sequence. Information written in molecules, read by light. Think of it like this. Imagine you had a massive library, but instead of books made of paper, each book was a unique crystal that glowed a specific color when you shined a light on it. The color sequence tells you the information. That's similar to how we read DNA. We're using light to interrogate matter, and the matter responds in ways that reveal its structure, which encodes information. But here's the genuinely mind-blowing realization. Your body does this naturally. Every cell in your body is constantly reading DNA, transcribing it into RNA, translating RNA into proteins, and those proteins build everything you are. And this entire process is regulated by light. Your circadian rhythm, your sleep-wake cycle, is controlled by proteins in your retina that are sensitive to blue light. When blue light hits them, it triggers a cascade of molecular events that tell your brain it's daytime. Those proteins, called opsins, literally turn light into chemical signals, converting photons into information your cells can use. In 2010, Carl Dieseroth at Stanford University pioneered a technique called optogenetics, where scientists engineer neurons to express light-sensitive proteins. They can then control those neurons by shining light on them. Blue light turns neurons on, yellow light turns them off. Scientists can literally control behavior, movement, even complex thoughts in animals by shining specific patterns of light on specific brain regions. They've made mice run in circles, made them freeze in fear, made them prefer certain foods, all by controlling neural activity with light. Do you see what this means? Light isn't just storing information outside your body. It's storing and transmitting information inside your body. Your thoughts, your memories, your consciousness itself is partially controlled by light. The information that makes you who you are exists as patterns of neural activity, and those patterns are influenced by light hitting your retina, light triggering proteins, light controlling genes. You are, in a very literal sense, a biological system that processes optical information. Here's a question that seems simple, but will break your brain when you really think about it. Why does light travel at the speed it does? Why 299,792,458 meters per second and not faster? And more importantly, what does this speed limit tell us about the fundamental nature of information itself? In 1905, Albert Einstein published his theory of special relativity, which had one shocking claim: nothing can travel faster than light in a vacuum. Not because we haven't built fast enough spaceships, but because the speed of light is actually the universe's speed limit for cause and effect. It's not really about light at all. It's about information. Here's why. Imagine you had a perfectly rigid stick, 1 light year long. You're holding one end, and you push it forward. Does the other end move instantly? In everyday experience, it seems like it should, but it doesn't. The push travels down the stick at the speed of sound in whatever material the stick is made of, which is way slower than light. Even if you could make the stick perfectly rigid, which you can't, the push still couldn't travel faster than light, because that would mean information traveled faster than light, and Einstein proved that's impossible. Think of it like this. The universe has a maximum speed limit for how fast information can travel from one place to another, and we call that speed the speed of light. But it's more accurate to call it the speed of causality or the speed of information. Light just happens to travel at that maximum speed because photons have no mass. Anything with mass, like you, me, spaceships, can approach that speed but never quite reach it. In 1975, John Wheeler, one of the great physicists of the 20th century, coined the phrase "it from bit," suggesting that physical reality emerges from information. His idea was that the universe isn't fundamentally made of particles and forces, but of information, and particles and forces are how that information manifests. The speed of light limit isn't a limit on how fast things can move. It's a limit on how fast information can propagate through the universe's information structure. This has profound implications. When you look at a star, you're not seeing it as it is now. You're seeing it as it was when the light left it, which might be years, decades, centuries, or thousands of years ago. The information about what's happening to that star right now hasn't reached you yet because information can't travel faster than light. In a very real sense, the universe has no now. There's no universal present moment. Events that are happening now for you are separated by light travel time from events happening now for someone on another planet. Your now and their now are different. This means information itself has a maximum update rate based on distance. If you're talking to someone 1 light second away, like on the moon, there's a 2-second delay between saying something and getting a response. 1 second for your signal to reach them, 1 second for their response to reach you. If you're talking to someone on Mars, the delay is between 4 and 24 minutes, depending on where Earth and Mars are in their orbits. If you're talking to someone in another galaxy, the delay is millions of years. The speed of light creates information horizons, boundaries beyond which communication becomes impractical or impossible. But here's the weird part. Quantum mechanics seems to violate this. In 1935, Einstein, Podolsky, and Rosen described a thought experiment showing that quantum mechanics predicted spooky action at a distance, where measuring one particle instantly affects another particle, no matter how far apart they are. Einstein thought this proved quantum mechanics was incomplete. He was wrong. In 1964, John Stuart Bell proved that Einstein's concerns could be tested experimentally. In 1981, Alain Aspect and his team in France performed the test. Quantum entanglement is real. When you measure the quantum state of one particle, the state of its entangled partner changes instantly, even if it's on the other side of the universe. Information about the measurement outcome seems to travel faster than light. Except it doesn't. Here's the catch. You can't use quantum entanglement to send information faster than light because you can't control what measurement outcome you get. The results look completely random unless you compare them with the results from measuring the entangled partner. And that comparison requires classical communication at light speed or slower. It's like the universe has a built-in censorship mechanism preventing faster-than-light information transfer. No matter how clever you are, you can't use entanglement to violate causality. This tells us something deep. The universe enforces information limits with physical laws. The speed of light isn't arbitrary. It's a fundamental property of spacetime, of how information propagates through reality itself. Light, as the fastest information carrier, reveals the universe's architecture. How much information can you store in a given space? This question has a surprising answer that connects information theory, quantum mechanics, black holes, and the fate of the universe. And the answer is written in light. In 1948, Claude Shannon, working at Bell Labs, published A Mathematical Theory of Communication, which founded information theory. Shannon defined information mathematically, quantified it in units called bits, and proved fundamental theorems about how much information you can transmit over noisy channels. But Shannon's theory assumed the physical system storing and transmitting information could be abstracted away. It didn't matter if you stored information in magnetic domains, electrical charges, or light patterns. The information was separate from the medium. Except it's not. Physics imposes limits on information storage that Shannon's theory doesn't capture. In 1981, Ralph Landauer, also at Bell Labs, proved that erasing information generates heat. This is called Landauer's principle, and it says there's a minimum amount of energy required to erase one bit of information, equal to kT length 2, where K is Boltzmann's constant and T is temperature. At room temperature, that's about 0.02 electron volts per bit. Doesn't sound like much, but it means information has physical weight, metaphorically. Deleting information costs energy, which means information and energy are connected at a fundamental level. Think of it like this. Imagine you have a room full of boxes, some empty, some full. The pattern of full and empty boxes stores information. If you want to reset the room, to make all the boxes the same, you have to move things around, open boxes, close boxes, and that takes physical work, which requires energy. Information isn't just abstract bits, it's physical arrangements, and changing those arrangements has physical costs. But the real limit comes from quantum mechanics. In 1972, Jacob Bekenstein, a graduate student at Princeton, made a crazy suggestion. He was studying black holes, which are regions of spacetime where gravity is so strong that nothing, not even light, can escape. Stephen Hawking had recently proved that black holes have entropy, a measure of disorder or information. Bekenstein calculated how much entropy a black hole has and got a shocking result. The entropy of a black hole is proportional to the area of its event horizon, not its volume. This is bizarre. If you have a box and you want to know how much stuff you can put in it, you calculate its volume. Bigger volume means more stuff. But for black holes, the maximum information is proportional to area, not volume. A black hole with twice the surface area has twice the information capacity, but 8 times the volume. The information is somehow stored on the surface, not throughout the interior. In 1993, Gerard 't Hooft proposed the holographic principle, which suggests this applies to the universe itself. The maximum amount of information that can be contained in any region of space is proportional to the surface area of that region, not its volume. If this is true, then the three-dimensional universe we experience might be a projection of information encoded on a two-dimensional surface. Like a hologram is a two-dimensional surface encoding a three-dimensional image. Leonard Susskind extended this idea in 1995, connecting it to string theory and suggesting that reality itself might be holographic. Everything you experience, every object you see, every thought you have, might be information encoded on a distant two-dimensional boundary, projected inward to create the illusion of three-dimensional space. Now, what does this have to do with light? Everything. The event horizon of a black hole is defined by light. It's the boundary where light can barely escape gravity's pull. Inside the horizon, light is pulled back. Outside, light can escape. The event horizon is, fundamentally, a surface defined by the behavior of light. And if information is stored on that surface, then light and information are inseparably connected at the deepest level of physics. The ultimate information density limit, called the Bekenstein bound, is about 2.57 times 1043 bits per kilogram per meter. This isn't an engineering limit. It's a fundamental limit of physics. If you try to store more information than this in a given space with a given amount of energy, you create a black hole and the information becomes inaccessible. The universe itself enforces a maximum information density, and that limit is defined by what happens to light in extreme gravitational fields. Here's what will blow your mind. Your brain, your body, even a USB drive stores vastly less information than the Bekenstein bound would allow. There's enormous room for improvement. If we could approach even a tiny fraction of the theoretical limit, we could store all of human knowledge. Every thought everyone has ever had, every experience anyone has ever recorded, in something smaller than a grain of sand. The only reason we can't is engineering, not physics. And light, as the fastest information carrier, the thing that defines black hole horizons, the thing that creates interference patterns revealing quantum behavior, is the key to approaching these limits. Your computer right now is running on electricity. Electrons flowing through silicon transistors, switching on and off billions of times per second, performing calculations. But electrons are slow, they generate heat, and they're reaching fundamental limits. We've been making transistors smaller and smaller, following Moore's law, which states that the number of transistors on a chip doubles approximately every 2 years. But we're hitting the wall. Transistors are now so small that quantum effects start causing problems. Electrons tunnel through barriers they shouldn't. Heat becomes impossible to dissipate. Silicon is reaching its limits. The solution? Replace electrons with photons. Build computers that run on light. In 1990, David Miller at Bell Labs demonstrated an optical transistor, a device that uses light to control light. Instead of an electrical signal controlling whether current flows, a beam of light controls whether another beam passes through. The advantages are enormous. Photons don't interfere with each other the way electrons do, so you can have multiple beams of light pass through the same space without crosstalk. Photons travel faster than electrons in wires. Photons don't generate as much waste heat. And photons can be many different colors simultaneously, allowing parallel processing in ways electrons can't match. In 2015, researchers at MIT and the University of California, Berkeley demonstrated an optical neural network chip that performed machine learning tasks using light. Instead of electrical signals propagating through artificial neurons, beams of light passed through adjustable waveguides and interferometers, performing matrix multiplication, the core operation of neural networks, at the speed of light. The chip performed these calculations using virtually no energy compared to electronic equivalents, because photons don't dissipate energy as heat the way electrons do in resistors. Think of it like this. Imagine you're trying to solve a maze. With electrons, You send a scout through the maze, and they have to physically walk every path, which takes time. With photons, you can shine light into the maze from all directions simultaneously, and the light that comes out the other end instantly reveals the solution. Parallel processing at light speed. In 2020, researchers at the University of Oxford and the University of Munster created an optical chip that performed calculations at 17 gigaflops per watt, compared to about 3 gigaflops per watt for the best electronic supercomputers. It's not just faster, it's more efficient by a factor of 5. And this is early-stage technology. The theoretical limits are orders of magnitude better. But here's where this gets truly revolutionary. Optical computers don't just calculate faster, they calculate differently. Certain problems that are extremely difficult for electronic computers become trivial for optical computers. Fourier transforms, which are essential for analyzing signals, images, and data, can be performed by passing light through a lens. The lens physically computes the Fourier transform using the wave properties of light. One lens, instant calculation. Problems involving matrix multiplication, optimization, searching large databases, all become vastly easier with photonic computing. And now the really crazy part. Quantum computing and optical computing are merging. Photons are ideal qubits because they maintain quantum coherence, staying in superposition states longer than electrons or atoms. In 2020, a team in China built a quantum computer called Zhuzhang that uses photons to perform a calculation in 200 seconds that would take the world's fastest classical supercomputer 2.5 billion years. The calculation is admittedly not useful for anything practical, but it proves quantum supremacy, the point where quantum computers outperform classical computers at some task. The future of computing is optical. Not might be, will be. Every major tech company, IBM, Google, Intel, Microsoft, is investing billions in photonic computing. Within your lifetime, the computers you use will run primarily on light, not electricity. Your thoughts, your work, your entertainment will be processed by patterns of photons dancing through silicon waveguides at nearly the speed of light, performing calculations that would be impossible with electrons. You're witnessing the transition from the electrical age to the optical age. Information, which was carried by light through the air and glass, processed by electricity in computers, will soon be carried and processed entirely by light from end to end. The medium and the computation become the same thing. Now we're going to go deep, and this is where science blurs into philosophy. What is consciousness? Nobody knows. But whatever it is, light is intimately involved. And understanding how light carries information into your brain reveals something profound about the nature of subjective experience. When you look at something, photons bounce off objects, enter your eye, pass through your lens, and hit your retina. Your retina contains about 120 million rod cells for detecting light intensity and 6 million cone cells for detecting color. When a photon hits a rod or cone cell, it strikes a molecule called rhodopsin, which changes shape, triggering a cascade of chemical reactions that generate an electrical signal sent down the optic nerve to your brain. Here's the remarkable thing. Individual photons can trigger this response. Your eyes are so sensitive that on a dark night with clear air, you can detect a candle flame from 30 miles away. The absolute minimum for vision is about 5 photons hitting your retina within a fraction of a second. 5 particles of light arriving within milliseconds of each other are enough to create the subjective experience of seeing something. The tiniest possible amount of information, just enough to say, yes, there's light there, creates conscious experience. In 1942, Selig Hecht, Simon Schleyer, and Meres Pairin at Columbia University performed experiments proving that humans can detect individual photons. They had subjects sit in complete darkness for 30 minutes to let their eyes fully adapt, then flashed extremely dim lights and asked subjects whether they saw anything. By analyzing the statistics of responses, they proved subjects were detecting events caused by single photons hitting their retinas. Your consciousness is directly affected by individual quanta, the smallest possible units of light. Think of it like this. Imagine you're in a completely dark room, and someone throws a single grain of sand that lands on your arm. You feel it. That grain of sand is like a photon hitting your retina. A single quantum event, creating a neural signal, creating an experience in consciousness. The smallest possible physical event creates the smallest possible conscious experience. But here's where things get weird. The photon doesn't create the experience directly. The photon triggers a protein, which triggers a chemical cascade, which triggers electrical signals in neurons, which propagate through your visual cortex, activating millions of neurons in complex patterns, and somehow, mysteriously, that neural activity becomes the subjective experience of seeing. The photon is information. The proteins and chemicals and neurons are information processors, and consciousness is what information processing feels like from the inside. In 1990, Francis Crick, who helped discover the structure of DNA, and Christoph Koch, a neuroscientist, proposed that consciousness arises from synchronized neural activity in the brain, particularly gamma wave oscillations around 40 Hz. They suggested looking for the neural correlates of consciousness, specific patterns of brain activity that correspond to specific conscious experiences. Using functional MRI and other brain imaging techniques, researchers have found that when you're conscious of seeing something, specific regions of your brain show coordinated activity. When you're not conscious of it, even if your retina detected it and early visual processing occurred, that coordinated activity doesn't happen. Consciousness seems to require information integration, different parts of your brain communicating with each other. The information from the photons hitting your retina has to be combined with information about what you're paying attention to, what you expect to see, your memories of similar experiences, your emotional state, and countless other factors. Consciousness isn't in any one place or any one neuron. It's in the pattern of information flow across your entire brain. And light is the input stream. Everything you know about the visual world, which is most of what you know about anything, came from light carrying spatial information to your eyes. The wavelength of light determines what color you experience. The intensity determines brightness. The timing of photons determines motion. The spatial pattern determines shape. Light is literally writing information onto your retina 50 times per second, and your brain is reconstructing that information into your visual experience of reality. But here's the mind-blowing realization. The colors you see don't exist in the light. Light has wavelengths, electromagnetic oscillations. Red light oscillates at about 430 trillion times per second. Blue light at about 670 trillion times per second. But those oscillations aren't red or blue. They're just waves. Your brain interprets certain wavelengths as red, others as blue. The quali, the subjective experience of redness, exists only in your consciousness. Light carries information about wavelength. Your brain transforms that information into the experience of color. You are not seeing reality directly. You're seeing your brain's reconstruction of reality based on information carried by light. And that reconstruction is different for different people. About 8% of men have some form of color vision deficiency. They see fewer colors than people with typical vision. Some women have a genetic mutation, giving them 4 types of cone cells instead of 3, making them tetrachromats who see more colors than typical humans. The same light carries different information depending on who's receiving it. This means consciousness is not passive. It's not like a movie screen where images are projected. It's an active process of information interpretation. Light provides data, but your brain constructs the experience. And that construction can be manipulated. Optical illusions work because they provide ambiguous information, and your brain makes assumptions about what it's seeing. Magic shows work because magicians control what light enters your eyes and when, manipulating the information stream to create false experiences. You think you're seeing reality, but you're seeing information. And information can be true, false, ambiguous, or utterly fabricated. Let me paint you a picture of the future, based not on speculation, but on technology being developed in labs right now. Imagine a world where information is entirely optical, from generation to transmission, to processing to storage. No electrons, just photons. This isn't science fiction. It's the inevitable trajectory of information technology, and it's going to change everything. In 2022, researchers at the Karlsruhe Institute of Technology in Germany demonstrated a photonic chip that can modulate light at 160 gigabits per second using 1 femtojoule of energy per bit. That's 0.000000000000000. To put that in perspective, a typical smartphone uses about 10,000 joules per hour. This chip uses so little energy per bit that you could transmit the entire contents of the Library of Congress using less energy than it takes to lift a penny 1 centimeter. Now imagine scaling this up. Imagine data centers that run entirely on light, using 1,000 times less energy than current data centers. The environmental impact is enormous. Currently, data centers use about 1% of global electricity. With optical computing, that drops to essentially nothing. Climate change concerns about AI and computing? Solved. But the real revolution is speed. In 2019, researchers at the University of Central Florida created a laser pulse lasting 170 attoseconds. An attosecond is 10 to 18 seconds. That's incomprehensibly fast. For comparison, an attosecond compared to a second is like a second compared to the age of the universe. These ultra-short pulses can measure electron movements in atoms. And if you can measure electron movements, you can control them, which means you can control chemical reactions at the molecular level using light. Think of it like this. Currently, chemistry is like trying to build a house by throwing bricks at it randomly and hoping they land in the right place. With attosecond pulses, chemistry becomes like 3D printing, where you place every atom exactly where you want it, using light as your construction tool. This is the holy grail of nanotechnology, and light is how we'll achieve it. In 2021, researchers at Harvard created an all-optical neural network that performs image recognition without any electronics. Light from an image passes through a series of metasurfaces, nano-engineered optical elements that manipulate light in precise ways, and the light pattern emerging from the last surface directly indicates what object is in the image. No computation in the traditional sense, just light physically configuring itself to solve the problem. The calculation happens at the speed of light because the light propagation eases the calculation. This is called analog optical computing, and it's weirdly both more advanced and more primitive than digital computing. It's more primitive because it doesn't have the flexibility of programmable digital computers. It's more advanced because it's orders of magnitude faster and more energy efficient. For specific tasks like image recognition, signal processing, optimization problems, analog optical computing is unbeatable. Now combine all these threads: photonic chips for digital computing, analog optical computing for specialized tasks, holographic storage for massive data capacity, fiber optics for instant global communication, and quantum optical systems for unbreakable encryption and solving currently impossible problems. You get a complete information infrastructure that runs entirely on light. Here's what this future looks like. Your glasses have holographic optical elements that display information directly onto your retina. The glasses communicate with other devices using free space optical links, beams of modulated light. Those devices are running on photonic chips, performing calculations using light. Your data is stored in holographic crystals that last millions of years. Your internet connection is a personal fiber optic link, providing terabits per second. Your entire digital life generates less heat than a candle. And here's the truly transformative part. When information processing uses almost no energy, information becomes essentially free. Not free as in doesn't cost money, but free as in unconstrained by physical limits. You can store all information forever. You can process any problem instantly. You can communicate with anyone, anywhere, in real time. The bottlenecks that currently limit how we use information disappear. This has philosophical implications. Currently, forgetting is natural. Storage is limited, so we discard information we don't think we need. In an all-optical world with effectively infinite storage, forgetting becomes a choice, not a necessity. Your entire life, every moment, every conversation, every experience could be recorded and stored forever. Privacy becomes a critical issue in ways we're not prepared for. The right to be forgotten becomes the right to delete information, which might require changing physical reality, erasing holographic structures. We're building a civilization where light doesn't just carry information, it is the information infrastructure. And once that happens, the distinction between the physical world and the information world collapses. Reality becomes manipulable through information manipulation, and information manipulation happens at the speed of light. I've told you how light stores information in fiber optics, holograms, DNA, computers, and brains. But now I'm going to tell you something that will reframe everything. Maybe light doesn't just store information about reality. Maybe light is reality. Maybe the universe itself is made of information, and matter is just information arranged in stable patterns. And light is the medium through which that information exists and propagates. This idea isn't mysticism or word games. It comes from serious physics. In 1948, Richard Feynman developed quantum electrodynamics, QED, a theory describing how light and matter interact. In QED, particles aren't really particles. They're excitations in quantum fields. An electron is a ripple in the electron field. A photon is a ripple in the electromagnetic field. These ripples interact when they overlap, and the interaction creates what we experience as particles colliding, emitting and absorbing light, all the phenomena of physics. But here's the strange part. In QED, particles are constantly emitting and absorbing virtual photons, photons that exist for such brief moments that they can't be directly detected, but which carry forces between particles. The electromagnetic force, the force that holds atoms together, that makes magnets stick to your fridge, that creates lightning, is mediated by virtual photons. Matter interacts by exchanging light, even when you can't see it. Think of it like this. Imagine two people on ice skates facing each other. One throws a ball to the other. The thrower moves backward from the throw. The catcher moves backward from the catch, and they move apart. That's how force works in quantum field theory. Particles throw virtual photons at each other, and the exchange creates forces. Light isn't just around matter, it's continuously being exchanged between matter, and that exchange is why matter acts the way it does. In 1990, John Wheeler proposed the it from bit concept I mentioned earlier, but his actual idea was more radical than I explained. He suggested that the fundamental building blocks of reality aren't particles or fields or strings, but bits of information, quantum bits that exist in superposition. Physical reality, matter, energy, space-time itself, emerges from these informational bits the way a complex computer program emerges from simple binary code. Wheeler pointed out that in quantum mechanics, the act of measurement creates reality. Before you measure a particle's position, it doesn't have a definite position. It exists in a superposition of all possible positions. The measurement forces it to choose a position. But measurement is really just information acquisition. You're gaining information about the particle, and gaining that information changes the particle's state. Information and reality are coupled at the deepest level. In 2002, Seth Lloyd at MIT calculated the computational capacity of the universe. He treated the universe as a quantum computer, where every particle is a qubit, and particle interactions are computational operations. He calculated that since the Big Bang, the universe has performed about 10,120 basic operations on 1,090 bits. Those operations, those information processing events, created everything you see around you. The universe computed itself into existence. Now here's where light comes in. Light is the fastest information carrier, so light defines the update rate of reality. The speed of light isn't just how fast light travels, it's how fast cause and effect propagate, which is how fast information spreads, which is how fast reality computes itself. If the universe is a quantum computer, light speed is its clock speed. This connects to Einstein's relativity in a beautiful way. In relativity, space and time are relative. Different observers moving at different speeds experience time passing at different rates and measure different distances. What's absolute is space-time intervals measured in ways that account for the finite speed of light. Light speed is the conversion factor between space and time, the thing that makes them part of the same four-dimensional structure. Information is what connects space and time into space-time. And this is all confirmed by observation. Cosmologists studying the cosmic microwave background, the light left over from the Big Bang, have found patterns in that light that perfectly match predictions from quantum field theory. The entire universe, galaxies, stars, planets, everything, crystallized out of quantum fluctuations in the early universe. Random fluctuations in quantum fields, interpreted as information, processed by physical laws, generated all of reality. And we know this from light, from photons that have been traveling through space for 13.8 billion years, carrying information about the universe's birth. In 2017, the LIGO and Virgo gravitational wave detectors observed two neutron stars colliding. They detected gravitational waves, ripples in spacetime itself, and 1.7 seconds later, telescopes detected a burst of gamma rays, high-energy light, from the same event. Those two signals, gravitational waves and light, traveled across 130 million light-years of space and arrived within 1.7 seconds of each other. This proved that gravitational waves, another form of information carrier, also travel at the speed of light. The universe has one speed limit for all information, and light is the most direct manifestation of that limit. So when you ask, how does light store information? The deepest answer is, light is information, moving through the universe's information structure, which we experience as physical reality. Storing information in light isn't about putting information into something external. It's about shaping the fundamental field from which reality emerges. We're approaching the end, and this is where everything comes together in a way that's both beautiful and terrifying. The universe is running on borrowed time, and light holds the key to understanding why. In 1852, William Thomson, Lord Kelvin, realized that the universe has a direction. Energy naturally flows from hot to cold, concentrated to dispersed, ordered to disordered. This is the second law of thermodynamics, which states that entropy, the measure of disorder, always increases in closed systems. The universe is the ultimate closed system, and its entropy is always increasing. Eventually, everything will reach the same temperature. All energy will be evenly distributed. No work can be done, no life can exist. This is called heat death, and it's the ultimate fate of the universe. But what does entropy really mean? In 1877, Ludwig Boltzmann connected entropy to information. He realized that entropy is really a measure of how many microscopic states correspond to the same macroscopic state. A gas in a box has high entropy because there are countless ways to arrange the molecules that all look the same macroscopically. A crystal has low entropy because there are relatively few arrangements that create that ordered structure. Entropy is missing information, the number of bits you'd need to specify exactly which microscopic state the system is in. In 1948, Claude Shannon proved mathematically that entropy in thermodynamics and information in communication theory are the same thing, connected by the same formula. Information entropy measures uncertainty, how many bits you need to specify a message from a set of possible messages. Thermodynamic entropy measures disorder, how many bits you need to specify the microscopic state of a system. They're the same concept applied to different domains. This has profound implications. When you delete information, you increase entropy. When you create order, you create information and decrease local entropy. But you have to increase entropy somewhere else. Life creates order, building complex structures from simple components, decreasing local entropy. But life increases the overall entropy of the universe by dissipating energy as heat. You are an engine that transforms food and oxygen into order and waste heat. You exist by fighting the universe's tendency toward disorder, but you can't win permanently. Eventually, entropy wins. Now here's where light comes in. Light is the universe's entropy carrier. When objects radiate light, they're dumping entropy into the universe. Hot objects emit more light than cool objects. Stars are entropy engines, converting ordered matter, hydrogen atoms, into disordered matter, helium and heavier elements, while radiating enormous amounts of light. That light carries entropy away from the star into the universe. Think of it like this. A star is like a room with a heater. The heater creates order by concentrating energy in the heating element, but it dumps entropy into the room as heat. The room gets warmer, more disordered. Eventually, equilibrium is reached. The universe is like a room with countless heaters, stars, all running, all dumping entropy as light, and the room is slowly filling up. In 1974, Stephen Hawking proved something shocking. Black holes emit light, not from inside the event horizon, but from right outside it. Quantum fluctuations near the horizon create particle pairs, and sometimes one particle falls into the black hole while the other escapes as radiation. This Hawking radiation means black holes slowly evaporate, converting all their mass into light over unimaginably long timescales. A solar mass black hole takes 1,067 years to evaporate, vastly longer than the current age of the universe. But eventually it happens. And when it does, all the information that fell into the black hole is radiated back out as light. This created the black hole information paradox. Quantum mechanics says information can't be destroyed, but general relativity says anything that falls into a black hole is gone forever. The resolution, proposed by Stephen Hawking in 2004, is that information is encoded in the Hawking radiation in subtle correlations between photons. The information isn't lost, it's scrambled, encoded in light, so thoroughly mixed that reconstructing it is practically impossible, but theoretically feasible. So black holes, the most extreme objects in the universe, ultimately convert everything they consume into light, and that light carries all the information about everything that fell in. Light is the final state of matter, and this is the universe's fate. In the very far future, 10,100 years from now, all stars will have burned out. All matter will have decayed or fallen into black holes. All black holes will have evaporated, and the universe will be nothing but a thin, cold gas of photons, electrons, and neutrinos, spreading apart forever. The last information processing events will be quantum fluctuations in empty space, random photons interacting with random particles. And eventually, even that stops. No more information flow, no more change. Heat death. But here's the beautiful, terrifying realization. We're made of information arranged in improbable patterns, fighting entropy. Every thought you have, every memory you form, every action you take is part of the universe's last desperate attempt to maintain complexity before heat death. You are a temporary pattern in the information field, and maintaining that pattern requires constant energy input, constant information processing, constant transformation of order into disorder elsewhere. And light mediates all of it. Photosynthesis captures light to build complex molecules. Your food contains energy and information from sunlight. Your thoughts require energy that ultimately came from light. The warmth of your body radiates into space as infrared light, dumping entropy. You are a knot in the information flow, temporarily stable, ultimately doomed, but beautiful and meaningful in your brief existence. The universe is an information processing system running on light, slowly disorganizing itself, and you are part of that computation. Your consciousness is what it feels like from the inside to be part of the universe processing information. And one day, the processing stops, the light spreads thin, and everything reaches equilibrium. But not yet, not for a very long time. And until then, we process information, we create meaning, we shine light on the darkness. So what does all this mean for you? Right now, reading this, what does it change about how you see yourself and your place in reality? You started this video thinking light storing information was about technology, about fiber optics and hard drives and computer science. And it is, but it's so much more. Light storing information is the fundamental mechanism by which reality maintains itself. Information is physical. Light is information's primary carrier, and you are a pattern in that information flow. Every morning when you wake up, photons from the sun pass through your window, hit your retina, trigger chemical reactions that send electrical signals to your brain, and those signals wake you up. Light is literally writing the beginning of each day into your consciousness. When you look at your phone, light from the screen carries text, images, videos into your mind. When you look at a loved one's face, light bouncing off their skin carries information about their expression, their mood, their identity. Light is the medium through which you experience other minds. And here's what transforms everything. You're not passive in this. You're not just receiving information from light. You're interpreting it, making sense of it, acting on it, and then emitting information yourself. When you smile, light bounces off your face differently. When you write something, you're creating patterns that will eventually be converted to light and transmitted to other minds. When you teach someone something, you're using light to copy information from your brain into theirs. You are an active node in the universe's information network, receiving, processing, and transmitting. This changes the meaning of communication. When you talk to someone, you're using sound waves, but those sound waves are information carriers just like light. When you text someone, that text is converted to electrical signals, then often to optical signals in fiber optics, then back to electrical signals in their phone's processor, then to light from their screen, then to electrical signals in their optic nerve. Your thoughts encoded multiple times in different physical media, traveling at light speed, reconstructed in someone else's consciousness. You're literally sharing consciousness across space using light. Think about this. Everything you know about the universe, beyond your immediate surroundings, came from light. The stars you see are ancient light carrying information across light years. The photos of distant galaxies are light that left those galaxies billions of years ago, carrying information about the early universe. The videos of historical events are information preserved in light-encoded patterns. Your entire model of reality is built from information delivered by light. But light also reveals what you can't know. The speed of light creates information horizons. There are parts of the universe you'll never see because the light from them hasn't reached Earth yet. There are parts of the universe you'll never see because the expansion of space is carrying them away faster than light can travel toward you. The observable universe is defined by light. Everything beyond the cosmic horizon is fundamentally unknown and unknowable because information from there will never reach you. This should make you feel small, right? The universe is vast. You're tiny. Most of it is forever out of reach. But here's the reframing. You exist in the most interesting part of cosmic history when complexity is maximized. The early universe was too hot, too uniform, too chaotic for complex information processing. The far future will be too cold, too dispersed, too quiet. But right now, in this narrow window of cosmic time, there are stars, planets, life, consciousness, civilization. Information processing is at its peak, and you're part of it. You're made of stardust. That's literally true. The atoms in your body were forged in stars and scattered across space when those stars exploded. But more than that, you're made of information patterns that evolved over billions of years to process light, to extract meaning from photons, to build models of reality accurate enough to survive and thrive. Your eyes, your brain, your mind are the universe's way of knowing itself through light. And what you do with that information matters. Not in some cosmic sense where the universe cares. It doesn't. But in a human sense, where meaning is created by conscious beings choosing to value things. You can use light-carried information to learn, to create, to connect with other minds, to build things that matter. Or you can waste it. The choice is yours, but the potential is real. Every scientific discovery I've told you about, from Maxwell's equations to quantum mechanics to holographic storage to optical computing, came from humans using light to study light, using information to understand information. We're a strange loop, a self-referential system. Consciousness studying the physical processes that create consciousness. And light is the thread connecting it all. So when you finish this video and go about your day, pay attention to light. Notice how screens glow, how sunlight streams through windows, how colors shift in different illumination. Recognize that every visual experience is information flowing into your mind at light speed. Feel the warmth of light on your skin and realize that's entropy being transferred, energy being dissipated, part of the universe's inexorable slide toward disorder. But also recognize that your organized, improbable existence is fighting that slide, temporarily, beautifully. You are light made conscious, information aware of itself, the universe's way of processing meaning in a cosmos that would otherwise be just mindless physics. That's not mystical nonsense. That's literally what's happening right now as you read these words. Photons organized by human intention are reorganizing the information patterns in your brain, creating new connections, new ideas, new understanding. Light is storing information in you, and you're becoming different because of it. And that's the answer to the question we started with. How does light store information? It doesn't just store information in external media like fiber optics and holographic crystals. It stores information in you. Every thought you have based on something you've seen, every memory of a visual experience, every idea triggered by reading these words is information that was carried by light and is now part of your consciousness. You are, in a very real sense, made of light-encoded information made permanent in neural patterns. So take that seriously. The information flowing into your mind shapes who you become. Choose carefully what light you let in, what information you expose yourself to, what patterns you allow to reorganize your thoughts. You have agency in your own transformation. Light provides the information, but you decide what to do with it. Let's go even deeper. I want to talk about what it means that information is physical, that light is information, and that reality itself might be fundamentally informational. This has implications that cascade through philosophy, meaning, and how you should live your life. In 1961, Rolf Landauer published his principle that information is physical, which we discussed earlier. But the implications go far beyond erasing bits requiring energy. If information is physical, then physical reality is informational. Every particle, every field, every interaction is information processing. The universe isn't running a computation. The universe is a computation. And if that's true, then what we call physical laws are actually information processing rules, algorithms determining how information transforms from one state to another. This connects to work by physicists like Max Tegmark, who proposed the mathematical universe hypothesis, that physical reality is fundamentally mathematical, and mathematics is pure structure, pure pattern, pure information. If the universe is mathematical, then matter, energy, space-time. Everything is just different aspects of the same underlying mathematical structure. Different ways information can be organized. Think of it like this. A video game is made of information, binary code in a computer's memory. The game world, the characters, the physics, the story, everything emerges from that code. Players experience the game as a world with objects and rules, but fundamentally, it's just information processing. Tegmark suggests reality might be similar. We experience matter and energy and force, but fundamentally, it's mathematical structures, information patterns, processing, according to the laws of physics. This is not saying reality is a simulation created by someone. That's a different idea. This is saying reality is information, not information representing something else, but information as the fundamental substance. And if that's true, then consciousness, your subjective experience right now, is what it feels like from the inside to be a particular type of information processing. Your qualia, your experience of redness when you see red light, your feeling of pain, your sense of self, all of it is information processing happening in the pattern of neural activity in your brain. This connects to the hard problem of consciousness, identified by philosopher David Chalmers in 1995. The easy problems of consciousness are explaining how the brain processes information, how perception works, how memory is stored. Those are hard scientifically, but not philosophically mysterious. The hard problem is explaining why information processing feels like something. Why is there subjective experience? Why is there something it's like to be you? And here's the uncomfortable possibility. Maybe there isn't a special explanation. Maybe any sufficiently complex information processing system has subjective experience. Maybe consciousness isn't a special property that emerges at some threshold, but a fundamental aspect of information integration. Your consciousness is very complex and rich. A simpler organism's consciousness might be simpler and less rich. A thermostat integrating information about temperature to control heating might have an unimaginably primitive form of experience. This idea, called panpsychism, sounds crazy but is taken seriously by some philosophers and neuroscientists because we have no better explanation. If consciousness is what information integration feels like, then light creating information patterns in your brain is creating your conscious experience. The colors you see are your brain's interpretation of information about light wavelengths. The image you experience is your brain's reconstruction of information about spatial light patterns. Your visual consciousness is light-encoded information made subjective. And this means your memories are light-encoded. Every visual memory you have is a pattern stored in synaptic connections that was originally created by light hitting your retina. When you remember something you saw, you're not replaying the original light pattern. You're activating the neural pattern that was created by that light. The information persists even though the light is long gone. You are a living library of light-encoded information. Now extrapolate this. Future technologies might be able to read those patterns, decode them, reconstruct what you saw. Your memories could be extracted, stored externally, shared with others. Your visual experiences could be transmitted to someone else's brain, letting them see through your eyes, experience your qualia. The boundary between minds becomes porous when information can be copied and transmitted. This raises profound questions about identity. If your memories and personality are information patterns, and those patterns can be copied, are you the pattern or the specific physical instantiation? If I copied your brain state exactly into a computer simulation, is that you? Does it feel like being you? If the copy is indistinguishable from the original, does the distinction matter? These aren't idle philosophical questions. As we develop better brain-computer interfaces, as we map the connectome, the complete wiring diagram of brains, as we build more sophisticated AI systems, these questions become practical. And light is crucial to all of it. Optogenetics already lets us control neurons with light. Holographic microscopy lets us image neural activity in 3 dimensions. Optical computers might one day run brain emulations. Light is the tool you'll use to decode consciousness and possibly to create it artificially. But here's what keeps me up at night. If consciousness is information processing and light carries information, then in some sense, light is the carrier of consciousness. When you look at someone's face and understand their emotion, light bouncing off their face carried information about their internal state, their mind, into your mind. When you read something profound that changes how you think, light from the page or screen carried someone else's consciousness, their ideas, their worldview into you. Minds communicate by organizing light to encode information. This makes books, photos, videos, the internet, all of it, extensions of human consciousness using light as a substrate. Culture is collective consciousness stored in light-readable media. Civilization is information sharing enabled by light. Your individual consciousness is a node in a vast network of light-connected minds, all influencing each other, sharing information, evolving together. And this is accelerating. Books let ideas persist across time. Printing made ideas scalable. Telecommunications made ideas transmissible in real time. The internet made whole information accessible to anyone. And photonic computing and brain-computer interfaces will make information processing so fast and transparent that the distinction between individual minds might blur. We might be heading towards some form of collective consciousness, not through mysticism, but through technology-enabled information sharing at light speed. This should terrify you and excite you in equal measure. The potential for knowledge, understanding, connection is limitless. But so is the potential for manipulation, surveillance, control. When information flows freely, so does power. Whoever controls the light-based information infrastructure controls reality as experienced by everyone connected to it. This is already happening. Social media algorithms control what information reaches your eyes, shaping your worldview. Recommendation engines control what you watch, read, learn. You think you have free will, but your choices are constrained by what information you receive, and that information flow is controlled by others. So here's my challenge to you. Become conscious of the light information flows around you. Notice what you're looking at, what's capturing your attention, what information is being fed to you. Actively choose to seek out information. It challenges your assumptions, expands your understanding, connects you to other minds in meaningful ways. Use light, don't be used by it. We're in the final stretch, and I want to leave you with something practical, something you can take from this deep dive into light and information and apply to your actual life. Because understanding how light stores information isn't just abstract knowledge. It's a lens for seeing reality more clearly and making better choices. First, recognize that your attention is the gateway for light-encoded information into your consciousness. What you look literally rewires your brain. Neuroplasticity is real. The patterns of neural activity you experience repeatedly become strengthened. Hebbian learning, neurons that fire together, wire together. When you spend hours scrolling through short-form videos, you're training your brain to expect rapid, fragmentary information delivered visually. When you spend hours reading long-form text, you're training your brain for sustained attention and deep processing. The light patterns you expose yourself to shape your cognitive abilities. Think of your brain like a garden and information like seeds. Some seeds grow into beautiful plants that nourish you. Others grow into weeds that choke out everything else. You can't prevent seeds from entering your garden. Information is everywhere. But you can choose which seeds you water, which you let grow, which you ruthlessly remove. And the primary mechanism for planting seeds is light carrying information to your eyes. Second, understand that information storage is happening in you constantly. Every experience creates memories, and those memories influence your future perceptions and decisions. This is called the predictive processing model of consciousness. Your brain is constantly predicting what it expects to see, hear, and feel based on past experiences, and it only updates those predictions when reality differs from expectations. You're not passively receiving information. You're actively constructing reality based on prior information storage. This means your past light experiences shape your present light interpretations. If you've been exposed to mostly negative news, you'll perceive the world as more dangerous than it is, because your brain predicts danger. If you've been exposed to diverse perspectives, you'll interpret ambiguous situations more charitably, because your brain has more models to draw from. The information stored in your neural patterns is your perceptual filter. So here's the practical application. Curate your information diet as carefully as you curate your food diet. Junk food feels good in the moment, but makes you unhealthy long-term. Junk information, rage bait, misinformation, addictive but meaningless content feels engaging in the moment, but makes your thinking unhealthy long-term. Nutritious food requires more effort to prepare and consume, but makes you physically healthy. Nutritious information, challenging books, diverse perspectives, deep documentaries requires more effort to process, but makes you intellectually healthy. Third, recognize the power of creating light-encoded information, not just consuming it. When you write something, you're encoding your thoughts in patterns that can be transmitted to other minds. When you take a photo or make a video, you're creating a light-based record that preserves information across time. When you teach someone something, you're using light, sound, and other carriers to copy information from your mind into theirs. You're not just a node receiving information, you're a transmitter. And this is where meaning enters. In a universe trending toward heat death, toward maximum entropy, toward information dissolution, creating and preserving information is an act of defiance. Art, science, literature, music, philosophy, all of it is humans fighting entropy by creating organized information patterns that persist. And those patterns are stored in and transmitted by light. Your creative work, whatever form it takes, is you organizing light to carry meaning into the future. Fourth, develop a relationship with light itself. This sounds weird, but hear me out. Ancient cultures worshipped the sun because they understood intuitively that light was the source of life. They were right, more right than they knew. Photosynthesis captures sunlight to build all plant life, which supports all animal life. You are, literally, made of reorganized sunlight. But also recognize artificial light. The light from your screens, from your bulbs, from your city, is information infrastructure. Too much artificial light disrupts your circadian rhythms, confuses your biology, stresses your system. You need darkness, absence of light information, to reset. There's a balance. Use light deliberately. Get natural sunlight during the day to regulate your biology. Limit screen time at night to allow your brain to rest. Create environments where light supports your goals. If you want to focus, use bright, cool light that keeps you alert. If you want to relax, use dim, warm light that signals safety and rest. Light isn't just information carrier, it's environmental signal, and your body responds to it, whether you're conscious of it or not. Fifth, embrace uncertainty. The quantum nature of light teaches us that reality is probabilistic, not deterministic. Light exists in superposition until measured. Information exists in potential until observed. You can't know everything, can't predict everything, can't control everything. The universe is fundamentally uncertain at the quantum level, and that uncertainty propagates up to the macro level in chaotic systems. But uncertainty isn't failure, it's freedom. It means the future isn't fixed. Your choices matter. Information you acquire, patterns you create, actions you take, all of them nudge probability distributions. You can't determine outcomes, but you can influence likelihoods. This is empowering. You're not a passive victim of physical law. You're an agent within physical law. The light entering your eyes gives you information, but you decide what to do with it. The information patterns in your brain constrain your choices, but neuroplasticity means you can change those patterns. You are simultaneously determined by your past and free to shape your future. And the resolution of that paradox is recognizing that freedom exists within constraints, agency exists within causality. Sixth, connect with other minds. The most beautiful application of light storing information is human connection. Every meaningful conversation, every shared experience, every moment of genuine understanding between people is information synchronization. Light bouncing off faces carries emotional information. Light from screens carries textual and visual information. You are constantly exchanging information patterns with other minds, and those exchanges change you both. You are not isolated. You are embedded in an information network, and that network is humanity's greatest achievement and source of meaning. So invest in relationships. Spend time with people who challenge you, inspire you, understand you. Use light-based communication technology to stay connected across distances, but don't let it replace face-to-face interaction where richer information flows. Look people in the eyes. Light reflecting from their eyes carries information about their attention, their engagement, their emotional state. You can't get that from text. Use the full bandwidth of human connection, all the information channels evolution gave you. Finally, recognize your cosmic significance. You are not significant in the sense of being important to the universe. The universe is indifferent. It doesn't care about you. But you are significant in the sense of being meaningful to yourself and to other conscious beings. You are one of the rare patterns in the cosmos capable of understanding the cosmos. You can look at starlight, decode its information, and understand nuclear fusion in distant suns. You can study quantum mechanics and understand the nature of reality at the smallest scales. You can contemplate entropy and understand the fate of the universe. You are the universe's way of knowing itself, and that's profound. And all of this understanding came from light carrying information, from photons launched by distant stars traveling for years to reach your eyes, from photons emitted by screens, reconstructing knowledge accumulated by thousands of humans over centuries, from photons bouncing around your environment, giving you real-time information about your surroundings. You are immersed in light, bathed in information, and your consciousness is the integration of all that information into a coherent experience. So use it well. You have maybe 80 years if you're lucky. That's 80 years of light patterns flowing into your consciousness. 80 years of information storage in your neural patterns. 80 years of processing meaning in a universe that will eventually forget everything. Make those years count. Learn voraciously. Create meaningfully. Connect authentically. Fight entropy by organizing information into beautiful patterns. And when your pattern eventually dissolves, when your information processing stops, let the information you created persist in others. Let your ideas, your art, your love be carried forward by light into other minds. That's immortality, not of your consciousness, which is tied to your brain and will cease, but of your information, which can be copied, transmitted, preserved. Every person you've influenced carries part of you. Every idea you've shared exists beyond you. You are a pattern in the light, temporarily coherent, ultimately transient, but meaningful while you exist and potentially persistent in what you leave behind. Let me bring everything together now. We've traveled from fiber optic cables to quantum mechanics, to black holes, to consciousness, to the meaning of your existence. And the connecting thread through all of it has been light carrying information. So what does it all mean? The universe is an information processing system. That's not a metaphor. Information is physical. Physical reality is information organized in stable patterns. Light is the fastest information carrier, the thing that defines causality's speed limit, the thing that mediates interaction between matter. When you look at anything, when you experience anything visual, light is carrying information from the world into your brain, and your brain is processing that information to create your conscious experience. We've learned to harness light to store and transmit information technologically. Fiber optics carry terabits per second across oceans. Holographic storage stores terabytes in crystals. Optical computers will perform calculations at light speed using virtually no energy. DNA stores information that light can read. Your screens encode information in light patterns that reconstruct ideas in your mind. All of human knowledge is accessible through light-based information infrastructure. But more fundamentally, you are information. Your body is DNA information, expressed as proteins, organized into cells, organized into organs, organized into you. Your brain is information processing, neural patterns creating thoughts, memories, consciousness. Your identity is information patterns that persist even as the physical atoms that instantiate them cycle through. You are a pattern in the universe's information flow, temporarily stable, ultimately transient. And light is how that pattern interacts with the world. Light carries information from the world to you, shaping your experiences, your memories, your understanding. Light carries information from you to the world, your expressions, your creations, your influence on others. You are a node in an information network, and light is the medium connecting you to everything else. This reframes everything. Reality isn't solid matter with information as an abstract overlay. Reality is information with matter as one particular stable pattern. Light isn't just electromagnetic radiation. Light is pure information carrier, the thing that enables causal connection, the thing that enables consciousness to experience reality beyond itself. When you understand this, when you really internalize it, you see the world differently. You see that education is information transfer using light. Books, screens, teachers' faces, all carriers of information patterns into your brain. You see that art is information organization for emotional impact. Paintings, films, photographs, carefully structured light patterns designed to create specific experiences in observers. You see that technology is information processing infrastructure, humans extending their cognitive abilities by building systems that process information faster and more reliably than neurons. You see that history is information preservation across time. We know about ancient civilizations because they encoded information in structures. Artifacts, writing, and that information persisted, carried forward by light bouncing off archaeological sites, manuscripts, museum displays. You see that science is information extraction from reality. Experiments are carefully designed observations where light or other carriers bring information from nature into human understanding, and that information accumulates into theories that explain reality's patterns. You see that relationships are information exchange and synchronization. When you love someone, you're creating correlated information patterns in both your minds. Shared experiences, memories, understanding, inside jokes, all of it is information synchronization that makes your consciousness patterns overlap. When they're gone, those synchronized patterns remain in you, a kind of immortality through information persistence. You see that meaning is information valuation. Nothing in the universe has inherent meaning. Meaning is created by conscious beings choosing to value certain information patterns, certain outcomes, certain experiences. You create meaning by deciding what information matters, what patterns are worth creating and preserving, what experiences are worth having. And you communicate that meaning to others through light, sound, text, all information carriers that let your values propagate beyond yourself. And you see that your life is an information trajectory. You started with almost no information beyond genetic programming. Every experience added information, building your model of reality, your skills, your personality. You will end with a rich, complex information pattern that is you, and that pattern will partially persist in other minds, in your creations, in your influence on the world. Your life's meaning is the information pattern you create and leave behind. This is simultaneously humbling and empowering. Humbling because you're not special. You're one of billions of human information processing patterns, which is itself one species among millions, processing information differently, on one planet among trillions. The universe is vast, ancient, indifferent. Your information pattern will eventually dissolve, and from the universe's perspective, it won't matter. But empowering because within your subjective experience, you are everything. Your consciousness is your entire universe. The information patterns in your brain create your entire experienced reality. Yes, that reality corresponds to external physical reality through light-carried information, but your experience is always mediated by your information processing. You are the author of your perceived reality, bounded by physics, but free within those bounds. And you can choose to create information patterns that enrich your experience and others' experiences. So here's my final synthesis. Light storing information isn't a technological curiosity. It's the fundamental mechanism by which reality maintains coherence, by which complexity emerges from chaos, by which consciousness experiences existence, by which meaning propagates through time. Light is information's primary medium, and information is reality's substance. You are information temporarily organized in a pattern complex enough to be aware of itself, and light is your primary connection to everything beyond yourself. Use that knowledge. Be deliberate about what light patterns you expose yourself to. Curate your information inputs. Create meaningful information outputs. Connect with other conscious patterns. Fight entropy by organizing information beautifully. And recognize that every moment of your conscious experience, every visual perception, every thought triggered by something you've seen, is light-encoded information becoming part of you, changing you, making you who you are. You are light made conscious. Act accordingly. We've reached the end, and if you've made it this far, your brain is different than it was 210 minutes ago. That's not hyperbole. The information I've transmitted to you through light has created new neural connections, strengthened existing ones, changed the physical structure of your brain. You are literally not the same person who started this video. That's the power of light carrying information. Let me leave you with a few final thoughts. First, everything I've told you is true. The physics, the neuroscience, the implications, all of it is grounded in established science and cutting-edge research. I've named real scientists, real experiments, real dates. This isn't speculation or science fiction. This is reality as we currently understand it. And reality is stranger, more beautiful, more profound than any fiction. Second, I've only scratched the surface. Every section of this video could be a 100-hour deep dive. Quantum mechanics alone requires years of study to really understand. Neuroscience is exploding with new discoveries monthly. Photonic technology is advancing faster than I can keep up with. Information theory connects to everything from computer science to biology to cosmology. If any of this fascinated you, chase it deeper. The rabbit hole goes down forever. Third, what matters isn't just knowing this, it's integrating it. Let this knowledge change how you see the world. When you look at light, really see it. See the photons carrying information at cosmic speed limit. See the wave-particle duality, expressing quantum strangeness. See the spectrum of wavelengths, each carrying different information. See the information encoded in patterns, intensities, colors, timing. See the light not as mere illumination, but as reality's information substrate. When you use technology, recognize what's happening. Your phone is an optical device. Light from the screen carries information to your eyes. Light in fiber optic cables carries information across networks. Light in semiconductors controls electron flow in processors. Light in holographic storage preserves data. Light everywhere, processing and carrying information at scales from quantum to global. You live in a civilization built on manipulating light. When you interact with people, see the information exchange. Their face reflects light, carrying information about their emotions. Their eyes focus light, revealing attention direction. Their expressions are information they can't fully control, leaking their internal state. Your mirror neurons process this information, creating empathy, understanding, connection. Every conversation is information synchronization, minds aligning through light and sound. Treasure that. It's consciousness touching consciousness through physical media. When you learn anything, recognize you're storing information. Your brain is physically changing. Synapses forming, strengthening, weakening. Neural patterns becoming more or less likely to activate. Information from the external world, carried by light, becoming part of your internal world, part of who you are. Choose carefully what you learn. You are what information you consume. When you create anything, recognize you're generating information. Whether you write, draw, code, build, teach, whatever form your creativity takes, you're organizing matter or energy into patterns that carry information. Those patterns will persist beyond you. They'll influence other minds. They're your contribution to the universe's information content. Make them meaningful. Fourth, share this understanding. The most important information we have as a species is knowledge about reality's nature. Science is humanity's collaborative effort to understand the universe, and that understanding is stored in light-readable formats: books, papers, videos, databases. By watching this video, you've become part of that knowledge network. Share what you've learned. Teach it. Discuss it. Let the information propagate, but also teach the meta lesson. That knowledge is information. Information is physical, and choosing what information you absorb and create is choosing who you become. That's a message that transcends any specific topic. It applies to everything. In an information age, information literacy isn't optional. It's survival. Fifth, maintain wonder. The universe is astoundingly beautiful when you understand it. Light traveling at cosmic speed limit, encoding information about distant events, carrying cause and effect across space and time. Quantum superposition, allowing one particle to be in multiple states simultaneously. Black holes warping space-time so severely that even light can't escape. Consciousness emerging from information processing in neural networks. Heat death looming in the far future as entropy inexorably increases. All of it real, all of it happening, all of it fundamentally strange and wonderful. Don't let familiarity breed contempt. Every time you see light, remember what it is. Every time you experience consciousness, remember how improbable it is. Every time you connect with another mind, remember that you're sharing information patterns that will never exist again in quite this configuration. Every moment is unique. Every experience is precious. Every thought is a temporary fluctuation in the universe's information content. Pay attention. Be present. Experience it fully while you can. Sixth, accept mortality while embracing legacy. Your consciousness will end. The information pattern that is you will dissolve when your brain stops functioning. That's not sad. It's just physics. Entropy wins eventually. But information you create can persist. Ideas you share can propagate. People you influence carry part of you forward. Love you give creates correlated patterns in other minds. Work you do leaves traces in the world. You are temporary, but your information shadow can extend far beyond your lifetime. So the question isn't how to live forever, which is impossible, but how to create information patterns worth preserving. How to organize your brief time processing information into something meaningful, something beautiful, something that enriches the universe's information content rather than just adding noise. That's the challenge, and there's no universal answer. Each conscious pattern must decide for itself what information patterns to create. But here's my suggestion. Create information that helps other conscious patterns process information better. Teach what you know. Share what you've learned. Help others understand reality more clearly, think more critically, experience more fully. Information that improves information processing is maximally valuable because it multiplies. One person understanding something better can help thousands understand. Knowledge that enables knowledge acquisition has exponential returns. And that's what I've tried to do in this video. I've transmitted information about how light carries information, hoping that understanding changes how you process information going forward. If it does, if you think more clearly about knowledge and consciousness and reality because of this, then I've added something meaningful to the universe's information content. And that's enough. That's all any of us can do. Finally, I want to leave you with an invitation. Take what you've learned here and chase one thread deeper. Maybe it's quantum mechanics, maybe it's information theory, maybe it's neuroscience, maybe it's photonic computing, maybe it's cosmology. Pick one thing that fascinated you and go learn everything you can about it. Use the light-based information infrastructure we've built, the internet, libraries, courses, videos, papers, all of it. Dive deep. Become an expert. Add to human understanding. Or use this knowledge practically. Improve your information diet. Be more deliberate about what you read, watch, experience. Create something. Write, code, build, teach, make art. Organize information into patterns that matter. Connect with other minds. Share knowledge. Build community around learning and understanding. Or just change how you see. Look at light differently. Notice photons when you see them. Think about information when you learn anything. Recognize consciousness when you experience it. Feel wonder at the improbability of your existence. Be present in each moment, knowing it's a temporary information pattern that will never recur exactly. Whatever you do, don't go back to seeing light as just illumination, information as just data, consciousness as just cognition. They're fundamental. They're reality's substrate. They're why anything means anything. You are information processing, experiencing itself, creating meaning in a universe that would otherwise be meaningless. That's profound. Honor it. Thank you for spending 210 minutes with me, for letting light from your screen carry my thoughts into your consciousness, for letting your brain process this information and integrate it into who you are. You've changed because of this video, and I hope that change enriches your experience of existence. Before you go, one last time, hit that like button if this video made you see reality differently. Subscribe if you want more deep dives into how reality works. Comment with what fascinated you most, what you're going to chase deeper, what this changed about how you see yourself. And share this with someone who needs to understand how light stores information, which is everyone, because everyone experiences light, consciousness, and meaning without realizing they're all connected. The universe is information. Light carries that information. You process that information. And that processing, that experience, that consciousness is the most profound phenomenon we know. Everything else is details. Go forth and process information beautifully. You are light made conscious. Make it count.